In 2013, a bold idea captured the imagination of the world. A transportation system so fast it could rival airplanes, but travel entirely on the ground. It was called Hyperloop. The concept promised something extraordinary. Passenger pods traveling through giant tubes at speeds of more than 1,000 kilometers per hour. At that speed, you could travel from Los Angeles to San Francisco in about 30 minutes. Cities hundreds of kilometers apart could suddenly feel like neighboring towns. The idea sounded like science fiction, but it came from one of the most influential technology entrepreneurs of our time, Elon Musk. In a white paper released in 2013, Musk described a futuristic system where pods would travel through low-pressure tubes, reducing air resistance and allowing extremely high speeds. Inside the tube, the air would be almost completely removed. Without air resistance, the pods could glide through the tube with very little friction. To move the pods forward, the system would use linear electric motors, similar to those used in magnetic levitation trains. In theory, the result would combine the speed of an airplane with the efficiency of a train. And unlike airplanes, Hyperloop systems could run entirely on electricity. The vision attracted enormous attention. Soon, several companies began racing to build the future of transportation. One of the most prominent was Virgin Hyperloop, backed by billionaire entrepreneur Richard Branson. The company built a test track in Nevada and began experimenting with prototype pods. In 2020, they achieved a historic milestone. For the first time, 2 passengers traveled inside a Hyperloop test pod. The world watched closely. It felt like the beginning of a new era of transportation, but there was a catch. The pod reached a speed of only 172 kilometers per hour. Impressive for a test run, but far from the 1,000 kilometers per hour promised by the original concept. And as engineers continued working on the system, the challenges became clearer. The first problem was the tube itself. Hyperloop requires hundreds of kilometers of near-vacuum tubes. Maintaining low pressure inside such a massive structure is extremely difficult. Even tiny leaks could affect performance. Then there is the issue of safety. What happens if a pod stops suddenly inside a sealed tube? How do passengers evacuate? How do rescue teams reach them? Designing safe emergency systems for a vacuum tube stretching across entire regions is a complex engineering challenge. Then comes the cost. Building Hyperloop infrastructure would require enormous investment. Elevated tubes, pylons, vacuum systems, power stations, and stations across cities. Some estimates suggest the price could reach tens of billions of dollars for a single route. At that point, many governments begin asking a simple question. Why not build high-speed rail instead? High-speed trains already travel over 300 kilometers per hour and are proven technology. They are expensive, but far less complicated than a giant vacuum tube system. And there's another challenge. Hyperloop requires extremely straight routes. At speeds approaching 1,000 kilometers per hour, even small curves would create intense forces on passengers. This limits where the system could realistically be built. Over time, some companies began to rethink the idea. In 2023, Virgin Hyperloop announced that it would shift its focus away from passenger travel and toward cargo transport. Moving freight inside vacuum tubes may be easier and safer than transporting people. For now, the dream of passenger Hyperloop travel remains uncertain. But the idea itself is far from wasted. Hyperloop has pushed engineers to rethink transportation infrastructure. It has inspired research in vacuum systems, magnetic levitation, and ultra-high-speed ground transport. And sometimes the most important technologies begin as ideas that seem impossible. The first airplanes were dismissed as impractical. The first electric cars appeared more than a century before they became mainstream. Hyperloop may still evolve. Or it may remain one of the most fascinating technological visions of the modern era. A reminder that the future is often shaped not only by what works, but also by the bold ideas that push engineers to try.